Hi everyone, Stephen here, and today I'm going to have a quick look at how we handle voltage in our API. At the moment I'm looking at our developers portal. If you are a developer and you're making your own application, or if you're using an existing application where you can integrate API calls, or even if you wanted just to develop a few custom spreadsheet functions, our API may be of use to you. You can see a list of our APIs by clicking on the API menu item. Today I'm interested in voltage, which is down here. This is one of our simplest calls, in that all we're going to do is send the voltage, and in return we'll get a slightly enhanced version. We can see the request URL here, and if you are registered on the developer portal, you can click the try it button to test out the API and see what the response is. For the video, I'm going to test the API using Postman, which is a very popular tool for testing APIs. I've now switched to Postman, and I've already set up the credentials so that we have access to our API, and I've added the base API URL here. I'm interested in the voltage API, so I'll enter the keyword, and the first parameter is the voltage. You can input whatever voltage you want. As 400 volts is a common voltage, I'll select this for demonstration. The second parameter is the phase angle of the voltage. Often when you're doing one-off calculations, you'll take the voltage as reference, so you can use 0. If you were doing a more complex system and wanted to look at the phase difference between voltages in various parts of the system, you could of course enter the actual phase angle. The final parameter is the phase. 3 will let our API know that we're looking at a 3-phase system. 4 would indicate 3-phase and neutral, 1 a single-phase system, and 0 a DC system. Now we've entered the API URL, I'll execute the command. And we can see that the data is returned. The phase is returned along with a description. We also have several flags returned, which indicate if it's an AC system, a DC system, or a low voltage system. These can be useful in your application. For example, you could use the is AC or is DC flag to decide if you need to show or hide a frequency input box. Following the flags, we have our first voltage. Typically within the API, we represent quantities as vectors in a complex form, and this is our interpretation. The value U is simply the voltage returned to you that you input. We can see here the magnitude is 400 volts and the phase angle is 0. We return the phase angle both in radians and degrees. Additionally, we return the real and imaginary values, not often used for voltage, but if, for example, this was an impedance property, these would indicate the resistance and reactance. We also return the cosine of the phase angle. Again, not often used in voltage, but if this was a current property, for example, this would be the power factor. The next voltage returned is U0. This is defined as the line to neutral voltage for AC systems, or L plus to L minus for DC systems. And we can see here that the magnitude is 230 volts, which is a line to neutral voltage for a 400 volt 3-phase AC system. Following that, we have ULL and ULN. For AC systems, these represent the line to line voltage and the line to neutral voltage. In this particular instance, they happen to be the same as U and U0. To illustrate the differences between the various voltages, I'm going to do 2 more API calls. The second one will be a single phase system. I'll change the voltage to 230 volts and the phase to 1 and make the call. In the return values we can see now that U is 230 volts, reflecting our input data. You note the line to neutral voltage is still 230 volts. For ULL and ULN we do have the three phase representations of 400 volts and 230 volts. And the final example is going to be a DC system. I'll choose 600 volts and set the phase to 0. As we can see, U returned 600 volts, which is what we supplied. You notice 600 volts, and because we are dealing with a DC system, ULL and ULN don't have any meaning, and the values returned are returned as not a number. And that's really it for how we represent voltage in our API. If you are developing an application, it is tempting just to represent the voltage as a single value. However, as the application grows, this can become more difficult to maintain. Using a class based on a representation similar to our API class gives you a lot more flexibility. I hope this has given you some insight into voltage, and thanks for watching.